So in the last class, we were talking about wedge shape film. So this is how the wedge shape is going to look like. Sorry. Here you have some material whose refractive index, let's say, is mu. The thickness of this film is varying continuously. यहाँ पे at this point your thickness is 0 and it keeps on increasing in this direction continuously. This is the direction of incident light. What would happen? आपकी incident light upper surface से reflect होगी and आपकी incident light, what would happen? It will, part of it will be refracted and which will move downwards, and जो आपका lower surface होगा वहां से आपकी जो light है वो refract होके आएगी. And these two waves, wave 1 and wave 2, they will interfere with each other, resulting in an interference pattern in wedge shape film. These are examples of the wedge shape film. आपके soap bubble में या आपके petrol on the road, all these are examples of wedge shape film because the thickness of these films is not uniform. The thickness keeps on varying. And look, if you look at here, the points, अगर आप इसमें जैसे देखते हैं, the points where the color is blue, that means at all those points the thickness of the film is uniform. और जो दूसरे color जहाँ पे है, wherever you are seeing continuously yellow color, that means at those points the thickness of the film is same. So this is a way to identify where is the thickness of the film uniform. जहाँ पे आपकी film की thickness uniform होगी, वहाँ पे आपको same color का pattern दिखना start हो जाएगा. And we'll discuss that why is that so. जहाँ पे thickness आपकी constant होगी, for example, वहाँ पे आपको red दिखाई देगा. फिर जहाँ पे thickness उससे थोड़ी सी different होगी, वहाँ पे आपको blue दिखाई दे सकता है. फिर और भी third place जहाँ पे thickness दोनों प्रीवियस केसेस से डिफरेंट होगी, वहां पे आपको पर्पल या येलो इस तरह के जो कलर्स आपको दिखाई देते हैं, दैट इज बिकॉज ऑफ द वेरिंग थिकनेस इन दीज काइंड ऑफ फिल्म्स और द surfaces. Let's talk about the derivation now. I just wanted to give you a better view of this 3D rather than my drawing. So if we talk about the derivation of this, in the last class we said that we are not going to do the derivation for this, but from our previous case of parallel thin film, if we talk about the wedge shaped thin film, where we said that the film would look something like this. This is your film now. In the parallel thin film, we said your path difference was 2 mu d cosine of r plus lambda by 2. Now in the wedge shaped thin film, if alpha is the angle between these two surfaces over here, the only difference is that you will get r plus alpha here. Without going into the derivations, we will stop here itself. From here, then we can easily derive the condition of minimum and maximum. If you want the maximum, then this path difference has to be equal to multiple of lambda. And from here, you can say that your 2 mu d cosine of r plus alpha is equal to 2n minus 1 lambda by 2, where your n has to start from 1 onwards. Similarly, for minimum, your this path difference, which is given by this expression, would be equal to where your n starts from 0 onwards. And from here, then you can say that this is going to be equal to r plus alpha is equal to n lambda, where your n starts from 0, 1, 2, and so on. So this will be your condition of maximum, and this will be your condition for minimum.
Ma'am, your voice is breaking.
Okay. Just give me a second. Okay, is it okay now?
Yes, ma'am.
Okay, so now these are your conditions of minimum and maximum. Apart from that, for example, in Newton's ring experiment, what you do is that you measure the diameter of the rings, right? You are more interested in finding out the diameter of the rings. Similar to that case, if you have a sideways look of this, अगर आपके पास wedge shape film है, अगर आप उसका sideways look की बात करो, it would look something like this, right? And before we go any further, as I said in the previous case, यहाँ पे this edge here will always look dark in the reflected light. और अगर रिफ्लेक्टेड में डार्क है तो ट्रांसमिटेड में ऑटोमेटिकली ब्राइट होगा, क्योंकि आपकी कंडीशंस ऑफ मिनिमम एंड मैक्सिमम आर अपोजिट इन रिफ्लेक्टेड एंड ट्रांसमिटेड. यहाँ पे ये डार्क क्यों होगा? द रीजन इज दैट दिस इज योर पाथ डिफरेंस एक्सप्रेशन. At this point, the thickness of this film is equal to 0. So this part of this expression becomes equal to 0, and you have a path difference of lambda by 2. And अगर आपका path difference lambda by 2 है, then irrespective of the color or wavelength of incident light, this edge will always appear dark in that case. Coming back to this, Hanji.
Ma'am, your voice is not clear.
Yes, ma'am.
Okay, let me rejoin the meeting. Just give me a second.